Yeah. Reference angles. Yes, I'd warned you guys that you'll need to know it. You've seen this unit circle thing, right? Yeah. What's special about that unit circle? Radius equals 1. Zero degrees here is referred to as the initial side. In other words, all angles start there at 0 degrees. And if we rotate a certain angle there, we get this green side, that is the terminal side. And let's say that that is at 40 degrees right now. So this angle would be 40 degrees. I'm also going to mark it out here as 40 degrees. But the thing is since it just wraps around a circle, there's nothing to keep it from going all the way around and back there. So when we have that green terminal side, it could be 40 degrees, but it could also be 400 degrees or 760 degrees. Or we could have gone the other way. We could have gone backwards and it could have been negative 320 degrees. Any of those angles would end up on that same green terminal side. Those are what we call coterminal angles. What is special about them? Why do we care? Well, remember the sine of that angle is that length. So let's type in the sine of 40 degrees, 0.6428. What do you think the sine of 400 degrees is? It's the same thing because it's in the same spot, it has the exact same sign. Or the sine of 760 degrees. Okay. So there are two concepts here. Terminal side is one concept. Those angles all have the exact same terminal side. So they're what's called coterminal with the 40 degrees. 40 degrees is also a reference angle. What makes it a reference angle other than the fact that that's the angle it is for all of those? What makes it a reference angle, remember we referred to this horizontal axis as a reference axis, a reference diameter. 40 degrees is the angle from that terminal side to the nearest reference diameter. So let's say my terminal side is over here. In fact, let's give that angle a value of 140 degrees. Its reference angle is right here. What's that reference angle going to be? 40 degrees. Why is that significant? What's the sine of 140 degrees going to be? The same, because it has that same reference angle. Angles that have the same reference angle will either have the same sign or opposite signs. What do I mean by opposite? Well, same number, one's positive, one's negative. Is there another spot here that has a 40-degree reference angle? Yeah, what would that angle be? This one was 140. This one will be 220. You got it. 40 degrees past 180. Guess what the sine of 220 is? Yeah, negative. Negative 0.6428. Any other place where there would be a 40-degree reference angle? What would that angle be? 320. How'd you get 320? Yeah, 40 degrees away from 360. The 220 was 40 degrees away from 180. And of course, the sine of 320 is also the negative 0.6428. Yeah, you can really see it right off the graph. So if I give you an angle like 248 degrees, what's its reference angle going to be? Well, it's usually easiest to find reference angle if we draw the unit circle. This is 0, 90, 180, 270. Which quadrant, 1, 2, 3, or 4, which quadrant is that angle going to be in? In 3, somewhere in here, right? So the reference angle has to come to this horizontal axis. So it's going to be right here. What's that value going to be? 68 degrees. Very good. What's the reference angle for? 171 degrees. 9. Very good. Right here it'd be 9 degrees. What's the reference angle for 295 degrees? What quadrant would 295 be in? Quadrant 4. So what's that angle? Yeah, it'd be going to 360, so it's gonna be 65 degrees. Simple enough. Since Mason asked for it, so if our terminal side is in quadrant 1, of course the sine is positive, right? The cosine here would be positive or negative? Positive. Now remember, tangent is equal to sine over cosine. So here the tangent would be positive. Positive divided by positive is a positive. Secant, 1 over cosine, right? Cosine's positive, secant's positive. Cosecant, positive, 1 over sine. If the sine's positive, the cosecant's positive. Cotangent, positive. It's the reciprocal of the tangent. If our terminal side is over here in quadrant 2, the sine is positive. Cosine, negative. Tangent, negative. A positive divided by a negative, sine divided by cosine, is going to be negative. Secant, negative, 1 over cosine. Cosine's negative, secant's negative. Cosecant, positive. It's the reciprocal of the sine. If the sine's positive, cosecant is positive. How about cotangent? Negative. Tangent's negative, cotangent's negative. Over here in the third quadrant, if our terminal side's in the third quadrant, the sine is negative. Cosine is negative. Tangent, positive, yes. Sine divided by cosine, negative divided by negative is positive. How about the secant? 1 divided by 1 reciprocal of cosine, right? It'll be negative. Cosecant, reciprocal of the sine, right? Cotangent, positive. If the tangent's positive, cotangent's positive. And if our terminal side comes over here into quadrant 4, Sine will be, that would be negative, right? Cosine is positive. So tangent, sine divided by cosine, negative divided by positive is a negative. Secant, remember secant goes off of cosine, right? So it's positive. Cosecant, negative. And cotangent, negative. Goes off of whatever the tangent is. So you can see here, all of them are positive. There is no section where all of them are negative, though, by the way. There are certain values that don't exist. For example, the tangent, OWI, yeah, he's going to be in jail for a while. Tangent is sine over cosine. One thing we can't do is we cannot divide by 0, right? So where is the cosine equal to 0? At 0 degrees, is the cosine 0? No, cosine's 1. How about at 90 degrees? Cosine 0. The tangent does not exist at 90 degrees. Any other places where the cosine 0? 180. So the tangent does not exist at 90 degrees or 180 degrees. Cotangent is the reciprocal. It's cosine over sine. So the cotangent doesn't exist where the sine is 0. Where is the sine 0? Well, the height, remember, sine is the height. Well, when is it right on the axis here? 0 degrees and 180. I screwed up here. This is not supposed to be 180. This should be 270 up here. 90 and 270. So cotangent doesn't exist at 0 and 180. How about secant? Secant's 1 over cosine. Cosine is 0 at, we already did that over here, 90 degrees and 270 degrees. And then, of course, cosecant is 1 over sine. So it doesn't exist where the sine is 0, which is 0 and 180. Now, this idea of reference angles is going to be very important for us as we do inverse trig functions. So far, we have only worked with right triangles. In a right triangle, can there be an obtuse angle? No, because they have to add up to 180. We've got a right angle, which is 90 degrees, so the other two angles have to add up to 90 degrees to make the 180 total. So all the other two angles have to both be acute. If this here is 12 inches and this down here is 15 inches, what's this angle here have to be? Well, this is the opposite side and the adjacent side. What trig function is that? Tangent. So I fill in what I know. Tangent, the angle is what I'm looking for here. Opposite side is 12, adjacent side is 15. And yes, since I'm looking for an angle, it's an inverse trig function. So theta equals the inverse tangent of 12 over 15, otherwise known as (38.66 degrees). However, Looking at our unit circled, knowing what we know about those reference angles. Oops. There are going to be other angles that have that same inverse tangent. 38.66 degrees is right here. Where else is the tangent positive? Over here, right? So that reference angle would have to be 38.66. That would be 218.66 degrees. Can that angle ever occur in a triangle? No, it cannot. So we don't have to worry about the tangent. Let's say we have a triangle here. This is our angle again. And let's say this over here is 8 inches and this over here is, well, let's call it 14 inches. What we have there is a sine. We're again looking for the angle. Opposite side is 8 and hypotenuse is 14. So to just make it short, our angle is the inverse sine of 8 over 14, which is, that sounds right, yep, 3485. But looking at our unit circle, that 34.85 is right here. Where else is the sign positive? Over here. Well, if that's 34.85, what is the, that's a reference angle, 34.85. What's this angle? 180 minus that, right? 145.15 degrees. Is it possible to have a triangle with an angle of 145.15? Now notice I didn't say right triangle, but a triangle. It is. Yeah, there, that could be 145 point, what does it say, 15? Yes, 15 degrees. Now, that's where we're going to start working on tomorrow, is these triangles like this called oblique triangles, sometimes referred to as Jasper triangles. Why are they called Jasper triangles? They're just not right. Yes. In your book, page 775, exercise 36-3, and page 778, exercise 36-5. I want you to work on those with these reference angles and coterminal angles. And tomorrow we